First, this is like, I don't know what the weighting here is. 70-30 on me? Maybe more? I don't know. On Thursday. On Thursday in class, I said, oh, we didn't finish. Happy weekend. No homework. Okay. Y'all were loud. Don't know who all heard that. But I never updated on plan book, and I did not know that until 7:20 this morning when Brooke decided to do her homework. I know, but since you're the one arguing it was crossed out, then I can only assume that you didn't see it until then. Okay. I got here this morning, I open up plan book, and I go to start setting up my thumbnails for the day for the streams and all that kind of stuff. I'm like, oh, oops. I said it, I didn't write it. And because Thursday and the last 3 days were all such a mess, I never went back and actually did it. When I say it's like a 70-30 thing, it's also because no one ever asked. Like, I get, like, you're supposed to look at plan book, yes. But there wasn't even a, like, hey, is plan book right? We didn't finish. Like, nothing. So, don't be scared. I just meme. Okay? So, if you tried grunting your way through it, I'd say that you had enough information to figure it out. But no one double checking, hey, we didn't finish, are we still supposed to do this? And no one asking questions on stuff that we did not yet get to. That's where I say, like, there's a little bit of give and take there, a little bit in both directions. Vast majority, me. I didn't do the thing. Okay? That's on me. But there's nothing wrong with just a text that says, is plan book right? Not 9:30 Sunday night, hey, did we have homework? You're going to get, I'm poke fun at you if that happens. I'm going to start making memes. But there's nothing ever wrong with just saying, is plan book right? As soon as someone said that, I would have pulled up plan book real quick, looked at it and said, oh, oops. Then I'd send out a message to everyone, reminder, you didn't have any homework. I didn't update it. Sorry, that's my bad if you already did. I'm already bringing brownies tomorrow. So, yes, it is brownie day. So here's what we do. Since we didn't finish, that means there will be no homework questions since you didn't ask about the stuff that you didn't even know how to do. And there's no daily quiz. Instead, we're just going to jump straight in. We're going to finish off 4-8. And then, entirely subjective, depending on how I'm feeling, we may either continue on and try to finish 4-9, or I might just say screw it and say you now have time to do your work. I don't know. Because, boy, was it a weekend. So, that is the plan. Okay? Yes, ma'am. Yes, you can. Can I have them back when we're done? Okay. It's in the pile that I took home that I never touched. Purple book, right? Blue. Blue and purple. and chapter 4 notes. There you go. Okay. No. This weekend was something else. So, I did not get to anything. Plus, Thursday was a white day, and white days I don't get anything done. Nope. There we go. So, let's try this. I don't remember how much of this we did. Oh, so we did this? Yay. Okay, then I want to back up to here. And, okay, so we're going to skip over 6 real quick. And I'm just going to say, can you do that? Do you remember how to do that? No radicals downstairs. But for 30, you have to multiply by the conjugate. Show me you remember what's what. Okay, if I remember right, there was no one in here who had allergies. Did we have any food allergy kids? Gluten, sugar, diabetic, eggs, lactose intolerant, milk no good. Lactose intolerant, you ingest any form of natural dairy product, the lactose molecule itself is unable to be digested, so your entire digestive system goes and attacks, and it hits the ejector button. Everywhere from mild noises to liftoff. So, no? No allergy kids? Okay. All right, then do these two. Do these two. Just like example 5. Just like example 5. There we go. Now we're working. What do we got? 4, 8, 10, 14, 17, 20.
I remember doing that.
It's plastic, like it's meant for non-stick coating. Like it does nothing. All right. Okay. Remember. Okay, this sounds familiar then, because we had one like this at the end. I only need to multiply by I on the first one. Remember, no radicals downstairs. 4 is okay. I know his dad. So we got 5i minus 2 plus 2i squared.
Plus, yeah, I squared.
Because if you did 4i or negative 4i or 0 minus 4i, didn't you just have to reduce by 4 at the end anyway? Okay. So after I do that, you've got to remember I squared is negative 1, I squared is negative 1. So if I have 5i minus 2 over a negative 4, I don't want to leave it like that. Separate your real friends from your imaginary friends, otherwise you won't have any real friends. So a negative 2 over a negative 4 is 1/2. And a 5i over a negative 4, I'm going to write it as minus 5/4 I. Because remember, I want to have all of my answers a plus bi. Because that's a complex number. Complex number is written as real part plus imaginary part. Where a is your entire real number, b is the coefficient of I. Okay. So in this case, you'd have an a of 1/2 and a b of negative 5/4. There's arguments about this, and we need to settle them before moving on to the other one. Are we okay with this? Okay. 5i over negative 4. Okay. Round 2. If I try to multiply numerator and denominator by just I, like a Yorkie going in a circle chasing your tail, right? You're going to get rid of this I, but you're going to put one here. And then you try to get rid of that one, you're going to put one over here. You try to get rid of that one, you put one over here, and you just back and forth and back and forth, back and forth, back and forth. So instead, we multiply by the conjugate. Conjugate is the exact same A and B, you just change the sign in the middle. Mistakes to avoid. Do not just cancel out the denominator and think it goes away. Why are you whispering angrily? No. All right. Up top. 3 by the stuff gets me 12 plus 9i. Negative 2i times the stuff gets me minus 8i minus 6i squared. 4 times the stuff gets me 16 plus 12i. Negative 3i times the stuff gets me negative 12i minus 9i squared. That's why we do it. We use conjugates. Well,
Instead of minus 12i twice, isn't it minus 9i?
no, in fact, it has to be the 12s twice because that's what cancels them out. You're going to have a positive 12i and a negative 12i. Okay? No, I want you to stop me with those questions. Too often, I just kind of get on a roll and go. What happens when I get to the end of the problem and then hey, that was supposed to be a negative 5 back here. And then I'll hear students say stuff like, you're just kind of in the zone, so we left you alone. Like, no, I want you to stop me if something doesn't make sense. Okay? Cool with green. Okay. Then I squared is a negative 1. I'll turn that into a positive 6 because it's minus 6 times negative 1. I squared is negative 1. I'll turn that into positive 9. 12i minus 12i cancels. So we'll have 16 plus 9 downstairs. I'll have 12 plus 6 is 18. I'll have 9 i's minus 8 i's is 1 i's. How do I write that as a complex number, a plus bi?
18 over 25 plus I over
1 over 25.
18 over 25.
Okay. No, I like that you guys said that. Okay, I can write this. I can write this. That is separating your real friends from your imaginary friends. But the one that the online interface that you're probably going to have to use at some point is going to accept is 1 over 25 I, like that. So it's bi, coefficient of I. Okay? And again, I'm not nitpicky about that. I will take all 3 of those when it comes time for a quiz. I'll take all 3. But you have to be aware, if you don't type this into the box and you're taking, I don't know, dual credit college algebra, or you go through pre-calc and trig and calc, and then you go and do, I don't know, dual credit calc to try to get the easy A or something after you've already gone through calc, then you're still going to have that interface. You're still going to have online like D2L, Blackboard, whatever the college is using, and you're going to have to type something or construct it like the, y'all are old enough. I don't know what level the 8th grade smarter balance looks like, but do you remember the like drag and drop to create an equation or a function or something? They'll have some interface like that where if you don't write it like this, it'll count it wrong. And that really sucks when you did it right. Okay? That's why I stress this, not because I care, but because I don't want you to get hammered later for, okay, don't say that to a room full of teenagers. I don't want you to get penalized later for laziness. Okay? It's Monday, not Friday. So, it means it's the beginning of the week. My kid's obsessed with that right now. Everything is what day is today, what comes after that, what comes after that, what comes after that. What day is today? Monday. What does that mean? It means you go back to preschool and your mother's sanity increases a little bit. So, factored form. What's the first stop on the factor train?
Divide by 2. You didn't say. Oh, you went.
Big kid voices. Close. I can't just divide and make it disappear. Factor it out. Okay? It doesn't just disappear. I'm not being just pedantic jerk there. I mean, you literally have to factor it out.
We're back a page.
Okay.
Yes, we are. I wouldn't lie to you about it.
Okay.
Oh.
So, if that was x squared minus 16. Well, the next stop on the factor train after GCF is are A and C perfect squares? Yup. Is there a middle term?
Psych. It's a Monday.
That it is. You're looking for factors of negative 16 that add up to 0 because there's no middle term. So I'd say x minus 4x plus 4. Okay. This is example. We're getting back to blue. Chill. I'm trying to connect to prior knowledge. It's an educational concept. Relax. This is called difference of squares. Okay. It's super, super easy. If I see a squared minus b squared, it factors into a minus b, a plus b. That's because if I were to take this thing out behind the shed and get a little beat down, if I said x squared minus 16 equal to 0, how would you solve by square roots?
Add 16.
Okay. Square root plus or minus 4. Because I put the square root there, I need to put the plus or minus. So here's the only difference. If that says plus, then I subtract it over. It's now negative 16. And we now know what is the square root of negative 16. Plus or minus 4i. So when I say x minus the 0 is the linear factor, that means the only difference because of the sum of squares is to jam an I right there. That's it. You can still factor the sum of squares the same way you did difference of squares. You don't even have to think. It's just square root of this guy, square root of that guy. Because it says plus, there's going to be a plus minus conjugate pair, and they're going to have i's. It allows us to start factoring things that weren't factorable before. Before we knew what I was, we would say non-factorable. In fact, it has a special name. It's called an irreducible quadratic because you can't factor it without going to imaginary numbers. But now that I have i's, this is not difficult. Take out the GCF if there is one, and use the sum of squares to factor it. Just know that now your factors are going to have i's in them. That's it. Let's see if you know your perfect squares. Pop quiz. What's the square root of 361?
16.
No. That's 256.
19.
It is 19. Okay. Know your perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on. Quick, what's 2 to the 7th? That's 2 to the 5th.
128.
It is 128.
Good calculator.
I don't. I just did.
That was definitely faster than a calculator.
Okay.
What happened? Yeah, he said it.
It took me like 30 seconds.
All right. That was more like Frank when he was back with his ex. Yeah. So, take out your greatest common factor, factor using sum of squares. Okay. It's that simple. Square root of x squared is x. Square root of 81 is 9. Because it's the sum of squares, it's going to be plus or minus 9i. That's it. Take out the 5. And then how does that factor?
X plus 2i. X minus 2i.
Okay. Now they don't have it here as an example. I want to show you, you can still do this when it's ugly. What if I had that? I want you to argue with your neighbors. Figure it out. Write it in factored form. Factored form. It will not be a pretty factored form.
I'm kidding.
What?
Well, I agree. I react that way to a lot of things, but that one was pleasant instead of ringing to me, so I just went for it. Okay, I will avoid that. Okay. Same as I did the other ones, except 3 isn't a perfect square. So, okay. Same thing, except because 3 isn't a perfect square, I have to write it as square root of 3. Now, this is a little bit higher of a skill. It'll come back to us in chapter 5. You will not, I don't think, you will see that in your homework. I know you won't see it. I'm 98% sure you won't see it on any quizzes. If you do, we'll review it beforehand. But I just wanted to see, could you figure it out if it's not a perfect square? Okay? All right, if we're going to go for broke, we're going to go for broke. Try again. I guarantee you won't get this in an assignment or a quiz. I just want to see if you can figure it out. Factor this out. Your answer will not be pretty. Not even close. I said it wasn't going to be pretty. But after seeing it, do you see what's going on? You take your GCF out. I recognize sum of squares. Sum of squares is going to say plus or minus the square root of this and the square root of this, but I have to make sure to simplify it. Square root of 8 is 2 square root of 2. Now, if that was 7x squared minus 8, there wouldn't be i's. But because it's plus 8, there are going to be i's. Okay? That would be like the challenge section at the end of the assignment kind of problem. Y'all are doing great in here, so I just wanted to toss it up there and see if we could figure it out. Like, that's next level for having just done factoring, having just learned about imaginary numbers. Okay? Does everyone see where it goes, though? Like, why these are the way they are? And because of the plus, that's what's getting minus? Or that's what's getting i's, sorry. Now, you can recreate this, too. If I say 7x squared plus 8 is 0, 7x squared is negative 8. Square root both sides, I got square root of 7x is square root of -8. Yeah. And then turn that into plus or minus 2 root of 2 over square root of 7i. So technically you have x plus 2 root of 2 over 7i. And then you'd have to rationalize, and then you'd have to remember to actually multiply them by the square root of 7. Blah, 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 blah. There's a bunch of stuff. We'll do more of it in chapter 5. But if you could get to yellow, you're doing great. Like, gonna crush it. Great. Okay, so we did a few of those. Are you cool with that sum of squares thing? Like, look at their numbers. Oh no, there's a fraction. Figure it out. Oh no, there's a fraction. The square root of a fraction is a fraction of square roots. Because the square root of 1 and the square root of 9 are 1 and 3 respectively. Okay, so don't be afraid of fractions just because, ew, fraction. All right? Then, finding imaginary solutions. This is not factorable. What factors of a positive 10 add up to a negative 3 Callister? Correct. How do we get it? Put the phone away. Said I'll treat you like an adult till you show me I can't. If we're trying to do math and you're over there blabbing away, well, freshman. So, if I'm going to go down the factor train, step 1, is there a GCF? No. Or A and C perfect squares? No. Okay, so is A equal to 1? No. So you follow that decision tree and you head all the way down to the AC method. In the AC method, I compare A times C, and I'm looking for what factors of 10 add up to my B term of negative 3. What factors of positive 10 add up to negative 3?
There's not K. You have to put an I in there.
But what's negative 5 times 2?
-10.
Negative 10, not positive 10.
So
Means it's not factorable because we can't find a pair of factors of 10 that add up to negative 3. Since it's not factorable, I have one of two ways of solving. Option 1. Oh no, we know how to solve them now. Option 1, complete the square. How do I complete the square? Y'all got a quiz tomorrow. You got to know how to complete the square. Uh-huh.
subtract the 5 over.
Okay. Blame Canada. Blame Canada.
Oh, subtract.
Divide by A. Getting x squared minus 3 halves x is negative 5 halves. And then complete the square by adding b over 2 squared to both sides. Right now, what is b? Negative 3 halves. What's half of that? Yes, just double the denominator. What's half of a half? Y'all cut pizzas. Maybe not straight, but y'all cut pizzas. I saw that the other day where someone took a picture of their pizza from like Domino's or something, and then they drew over the picture to show where the actual cut lines are, and it's like, that's the way their pizza came out of the box. Ew. So, if I'm going to complete the square, I'm going to add b over 2 squared to both sides. Half of 3 halves is 3 quarters. 3 quarters squared is 9/16. This is now a perfect square trinomial. It can be factored into the form x plus b over 2 squared. It's always going to be half of b and the square root of c. That's what makes it perfect. Get common denominators. Negative 40 eighths plus 9 eighths is negative 31. 16ths. It's still negative 31, but here we go. Solve by square roots. Square root of this, square root of this. X minus 3 quarters is plus or minus I root of 31 over 4. 31 can't be simplified, so it's just square root of 31. But now we know, this is something we couldn't have done last week. Now we know that the square root of a negative number just has an I. So I just throw an I there. And square root of 16 is 4. So I get down to the end of the rainbow and say x is 3 quarters plus or minus square root of 31 over 4. I'm going to put the I at the end so that it's in a plus bi form. Option 2, I don't want to complete the square. The directions did not tell me to solve by completing the square. So I'll do whatever the fornication I feel like. I'm going to quadratic formula. Negative b plus minus square root of b squared minus 4ac all over 2a. Plug your a, b, and c in there. b, a, c. This part, this part, 9 minus, here's 10 by 4 is 40, so 9 minus 40 is negative 31. 2 by 2 is 4. Simplify your radical. Write it as a complex number. It depends. This one, because of the particular fractions where you needed common denominators, yeah, I probably would have gone with quadratic formula as well. Personally, I prefer complete the square. It's my jam. I'm more comfortable with it. On these, it doesn't say how to solve it. It just says solve it. Solve it however you're going to solve it. If you prefer quadratic formula, go for it. I'm just going to tell you, you're going to need to complete the square at some point. Like, it pops up a lot later in math. There's a good chunk of you that are on my roster for pre-calc next semester. You will complete the square multiple times in a problem. And by that point, most kids look at it and they just laugh because it's easier to do complete the square. It takes until the end of pre-calc before kids believe me, and they'll do complete the square instead of quadratic formula. Because, oh wait, this is easier. Okay, I know it doesn't feel like that now. I'm just saying you have to know how to do both, but which one you do right now, I don't care. You do whatever you're going to do. Whichever way you want, go. Yeah, both. Negative 5 half is 5 negative 2 squared. 4, so it's going to be plus 1. Negative 2/3. Negative 1/3. So that's going to be negative 1/3, negative 1/6, 1/36, negative 2/3, negative 24/3, 24/36, 23/36. Fight me. Prove me wrong. Now remember, if you're talking about math, I want you talking to your neighbors. I want this to be group work.
Oh, yeah.
Are we getting there?
From 2002. At the bottom. When you walk at the bottom of it, it says 2002. Yeah, that's what, like, yeah.
Negative 2/3, 1/3, 136, plus 136, 3 by 3, 24. Oh no, is that a 22? It is?
That's 22.
2/3, 20. Oh! Alright.
That becomes. And then easy done.
16 minus 28. 4 over 2 is 2 and squared.
He's doing complete square.
Okay, whether you do complete the square or quadratic formula, plug in A, B, and C. Say a negative negative 4 is 4. 16 minus 20 squared negative 4 over 2. Simplify. Squared negative 4 is 2i. So 4 plus or minus 2i over 2. Remember, math is communist. What you do for one, you do for all. Divide by 2, divide by 2, divide by 2. 2 plus or minus I. You now have what you need to solve every quadratic in existence. Every quadratic in existence, you now have the tools to deal with. Up until this lesson, almost everything that we did was review. 3 variable systems, those were new. We just moved those down to Algebra 1 this year. Because they actually follow after 2 variable systems very easily while you're right in the thick of it. Absolute value graphs, transformations form. Remember, like up, down, left, right, stretch, compress, reflect, all that kind of stuff. That was kind of new. You cover it, but not to that depth. Otherwise, it's all been review until we hit this. We spent all this time on quadratics for a reason. Because as of Thursday, we're in polynomial land. Polynomial means we're not in quadratic city anymore. Now it's cubics, quartics, quintics. Now it's 6 terms long. Find all of the zeros. Only 3 of them are real. Okay? We need these tools because the goal of all of the polynomial stuff is to take polynomial and cut it down to quadratic. because I know how to deal with quadratics. Okay? There's a reason we spent so much time on this. Yep. Okay. So here I go showing my age. Like, I used to think this was a relevant reference until I realized that the movie is over 20 years old. You seen the original Matrix? Anyone? No? All right. Right? Neo is the chosen one. He is brought to go see the Oracle. The Oracle has all of these potentials in her room, and there's this little Tibetan monk kid sitting there just staring at spoons and bending them. And he asks the kid, "How do you do that?" And he says, "First, you must understand that it's not real. There is no spoon. It is not the spoon that bends, it is only yourself." Because they're in the Matrix, and the Matrix is a computer simulation, and it's all fake. Meaning, imaginary numbers, fake. But you can still work with them. Just like little Tibetan boy was able to bend spoons because he wasn't really bending spoons, he was just thinking at a computer. I'm a geek, we're done. So, starting with, ladies.
That's fair.
That's extremely beyond fair.
So if we already did that.